This is Group 1032's final presentation and product for Engineering 29, Manufacturing and Design Communication by Marcus, Joseph, Alex, Alejandro, and Wen Yang. Initially, our project was going to be focused on shoe trees, but after our design review, we understood and further decided that this product was not unique enough and could not be innovated on. We then moved our attention to a foldable upper bunk nightstand. And after realizing that this product was one that, as a group, we were not wholly intrigued about, we decided to instead choose a product that would solve an issue that we had all encountered and that we were all motivated to solve. After many trials and tribulations, our group decided to design and manufacture a phone mount for one's bike, given that it's a product we're truly passionate about. All members of our group, as relatively avid bikers, have all experienced the same issue of what to do with your smartphone when you're biking and need directions. We wanted to create an adjustable phone mount that would maintain a sturdy hold on your phone while the user was biking. Our product would be able to solve the issue of how bikers can use their phone while simultaneously biking, as well as making biking safer by preventing bikers from getting distracted and looking at their phones. Our envisaged target market is bikers all around the world who are experiencing the problems and issues that we have set forth to solve. One major decision that we had to make was how to create an adjustable clamp that would attach to any bike frame, no matter the size. For example, there are hexagonal, oval, and cylindrical bike frames. In order to solve this, we used a butterfly nut and bolt in order to secure the bike mount part of our product to the bike's metal frame. Another monumental design choice that influenced our final prototype was when we had to decide on how to make and manufacture a phone mount that would clamp and fit any type of phone while also allowing the biker access to buttons on their phone. For example, the power button, the volume button, and the home button. In order to solve this, we used standard nuts and bolts to very securely tighten around the phone and maintain a sturdy hold, while also leaving the main buttons on the phone able to be accessed by the specific way that we CAD'd our design. The phone clamp itself works very well in initiating and maintaining a solid clamp. However, we want to figure out a better way to turn the screws in order to create more friction. The portion of our mount that clamps to the bike is also fairly effective at clasping and fastening itself to the bike's riser bar. One way in the future we could improve our design is to create an easier way to tighten the screws on the phone clamp portion of our mount. Another way that we would like to improve our design is to make the walls of the phone clamp thinner in order to gain more access to the phone's screen. Given more time, resources, and money, we would also like to add an external battery to the outside of the phone mount, given that we have ample room in our current design. Moreover, in a future iteration, the last idea we would like to implement is creating a static tilt of roughly 10 degrees in our phone mount in order to make the phone easier to read when biking. We are satisfied with our materials and prototyping processes, and in our final prototype, we had used 3D printing to manufacture our bike mount. Although we're satisfied with our final prototype's materials and processes, given more time and cost not being a limiting factor, we think we could have achieved a much more optimized and sturdy final product with very little room for error. For our final prototype, we wanted to use water jet cutting and CNC metal cutting. However, cost was a limiting factor for us, as we had to provide our own metal plate to cut on, and a 24-inch by 24-inch by half an inch plate was $90. For our initial prototype, we decided to 3D print our bike mount, which proved to be very effective. However, on a very hot day, PLA could melt and deform, causing future issues with our product. If we were to make a more refined prototype, we would want to use CNC metal cutting process in order to obtain a sturdy and durable final product. If we were to scale up to address a full target market, we would definitely move away from 3D printing and more towards CNC metal cutting and water jet cutting.